If you've been following recent discoveries, you'll know our solar system has once again been visited by something extraordinary, a traveler from the stars known as 3I Atlas. This object, first detected in July 2025 by the NASA-funded Atlas Survey Telescope in Chile, is the third confirmed interstellar object to pass through our cosmic neighborhood. Unlike any comet born within our solar system, 3I Atlas came speeding in at nearly 58 kilometers per second, tracing a hyperbolic orbit, the unmistakable signature of an object that hails from interstellar space. In simpler terms, it's just passing through. When it was first identified, astronomers rushed to observe it, scrambling to collect data before it slipped away into the void. At that point, only a handful of studies existed, but even the early observations hinted at something unusual. This comet wasn't behaving like any we'd seen before. Initial brightness measurements showed that it was highly active, releasing gases and dust far from the sun, long before typical comets would start to sublimate. That meant one thing: it likely contained exotic, hyper-volatile materials, substances capable of vaporizing even in the cold reaches of deep space. Scientists also estimated its age to be anywhere between 3 and 11 billion years, potentially predating the formation of our own solar system. If true, 3I Atlas could be a fragment of a planetary system that no longer exists, a relic from the early days of our galaxy. To put it in perspective, it joins a very short list of known interstellar visitors: Oumuamua, the mysterious cigar-shaped object that zipped past us in 2017, and 2I Borisov, the more traditional-looking comet discovered in 2019. But compared to both, 3I Atlas appears to be faster, older, and far more active. Each of these cosmic visitors has rewritten what we thought we knew about planetary systems beyond our own. And now, 3I Atlas is offering scientists another rare opportunity, a direct look at material forged around another star billions of years ago. What secrets could it hold about its birthplace? And what can its strange activity tell us about the diversity of worlds that exist beyond our sun? In the next chapter, we'll discuss the latest mysteries regarding this interstellar wanderer, hoping to uncover the truth behind its mysterious glow. When a new interstellar object is discovered, time becomes the astronomer's greatest enemy. 3I Atlas is moving so quickly through the solar system that every observation window counts. Thankfully, two of humanity's most powerful observatories, Hubble and James Webb, turn their gaze toward this strange visitor, giving us a clearer look than ever before. On July 21st, 2025, the Hubble Space Telescope captured a series of detailed images when 3I Atlas was still 446 million kilometers from Earth. Even from that distance, Hubble's precision revealed something remarkable: a delicate teardrop-shaped coma surrounding a faint, icy nucleus. The comet's apparent brightness had misled earlier estimates, but Hubble's high-resolution data allowed scientists to separate the light of the nucleus from the surrounding dust. They discovered that the nucleus was much smaller than expected, somewhere between 440 meters and 5.6 kilometers in diameter. Far tinier than early models suggested. That's still larger than Oumuamua, but considerably smaller than Borisov, placing 3I Atlas right in between its two famous predecessors. Its speed, around 58 kilometers per second, confirmed that it wasn't bound by the sun's gravity. Then came the James Webb Space Telescope, with its unmatched ability to study the invisible, the infrared wavelengths where ices and gases reveal their secrets. Using its near-infrared spectrograph, Webb's team, led by Dr. Martin Cordner, measured the chemical fingerprints of the comet's coma. What they found surprised everyone. The spectra indicated strong signs of carbon monoxide, CO, and carbon dioxide, CO2, gases that vaporize at extremely low temperatures, while water vapor was still relatively weak. This means that 3I Atlas began releasing gas much farther from the sun than ordinary comets, likely due to these hyper-volatile compounds that sublimate in deep space cold. Even more intriguing was the pattern of dust movement. Normally, a comet's tail streams away from the sun, pushed by solar radiation. But in the Webb images, dust could also be seen emanating toward the sun. This suggested that the grains were fragmenting and scattering light as they moved, possibly accelerated by jets of CO2 gas bursting from beneath the comet's surface. Together, the Hubble and Webb observations paint a picture of a comet both fragile and restless. These telescopes have shown us that 3I Atlas is not just another comet, it's an active, volatile survivor from another world, offering us a fleeting glimpse into a frozen piece of galactic history. When astronomers thought they had begun to understand 3I Atlas, it did something no one expected. It suddenly became 5 times brighter than predicted. This wasn't a subtle flicker or measurement error, it was a genuine surge in brightness that baffled scientists around the world. The story begins with NASA Transiting Exoplanet Survey Satellite, better known as TESS. Although TESS was designed to find exoplanets by monitoring the brightness of nearby stars, its wide-field cameras also happened to capture countless other celestial objects, including comets. When researchers went digging through old TESS data, they discovered that 3I Atlas had been quietly observed a full month before its official discovery, between May 7th and June 2nd, 2025. This archival data offered a rare gift, a glimpse of the comet before it became famous. Astronomers Adina Feinstein, John Noonan and Darrell Seligman analysed these early images and found that as the comet approached the inner solar system, its brightness should have increased slightly, maybe by a factor of 1.5. But instead, the comet's light output quintupled, a jump far beyond what sunlight reflection alone could explain. That meant one thing: 3I Atlas wasn't just reflecting more sunlight, it was producing more of its own through powerful outgassing. The comet was already active at enormous distances, around 6 astronomical units from the Sun, nearly the orbit of Jupiter. Ordinary comets don't begin outgassing that far out because water ice remains frozen solid, so what was fueling it? The leading theory points to exotic hyper-volatile ices, materials like molecular hydrogen or nitrogen that can sublimate in the extreme cold of deep space. These substances could explain why 3I Atlas flared up so dramatically when it was still far from solar warmth. In essence, the comet was waking up early, venting gases long before it should have. This early activation hints that 3I Atlas may have formed in an exceptionally cold and distant region of its original star system, perhaps beyond the equivalent of a Kuiper belt where only the most volatile materials can remain frozen. And when it was ejected into interstellar space, those same materials became time capsules, preserving a record of alien chemistry for billions of years. What TESS uncovered wasn't just a brightness anomaly, it was the first clue that this object might be unlike any comet we've ever studied. Its unusual light curve, intense, unpredictable, and possibly driven by strange volatiles, makes 3I Atlas one of the most active interstellar visitors yet observed. And if that's the case, this comet could be our best window yet into what truly lies beyond our sun, a messenger from a place so cold and ancient that even sunlight struggles to reach it. While space telescopes revealed the broad structure of 3I Atlas, the real chemical detective work came from the ground. In August 2025, scientists turned the powerful Gemini South telescope in Chile toward the interstellar comet, capturing it in vivid multicolor detail. What they found next added an entirely new twist to its story. Gemini's multi-object spectrograph recorded not only the comet's growing coma, but also a distinct faint tail stretching across the background stars, proof that 3I Atlas was becoming more active as it neared the Sun. Even more exciting was what its spectrum revealed. Within the faint blue glow of the coma, astronomers detected a clear emission signature of cyanide CN gas. This was the moment that confirmed 3I Atlas was a true comet, not a dry rock like oumuamua. Cyanide forms when hydrogen cyanide, HCN, is released from the comet's ices and broken apart by sunlight. The detection meant that sunlight was now warm enough to sublimate water ice, freeing trapped molecules from deep inside the nucleus. But when researchers measured the balance between cyanide and diatomic carbon, C2, they noticed something strange. 3I Atlas was carbon chain depleted. In comets, carbon chain molecules like C2 and C3 help scientists trace where and how they formed. A deficiency in these compounds suggests the comet's birthplace was extremely cold, where heavier carbon molecules couldn't easily form or survive. That points to an origin far from its parent star, perhaps in the frigid outer reaches of an alien solar system, a region analogous to our own Oort cloud. Curiously, this isn't the first time astronomers have seen such a pattern. The interstellar comet 2I Borisov shared the same chemical trait: strong cyanide emission, but a noticeable lack of complex carbon chains. It's possible that both Borisov and 3I Atlas originated from similar types of planetary systems: cold, distant, and rich in simple ices, but poor in organic complexity. That raises fascinating questions. Do most interstellar comets form in such icy, carbon-poor environments? Or have we simply been lucky enough to sample two from the same kind of star system? Whatever the answer, Gemini's detection of cyanide and the chemical fingerprints hidden within it transformed 3I Atlas from a faint smudge in the sky into a messenger of chemistry from another world. Just when it seemed that 3I Atlas couldn't get any stranger, astronomers discovered something truly unprecedented. It was reflecting light in a way no comet ever had before. To understand this, we need to talk about a powerful but often overlooked tool in astronomy: polarimetry. Polarimetry doesn't just measure how bright an object is, it measures how the light is oriented after bouncing off dust or gas. By studying this orientation, or polarization, scientists can infer a comet's grain sizes, surface texture, and even the structure of its coma. In September 2025, astronomer Zuri Gray and her team published the first ever polarimetric observations of 3I Atlas, using telescopes across Chile, the Canary Islands, and Bulgaria. Their findings shocked the community. 3I Atlas displayed an exceptionally deep and narrow negative polarization branch, meaning the light was polarized parallel to the scattering plane, instead of perpendicular to it, as seen in most comets. This behavior had never been observed before for any interstellar object, asteroid, or comet. In simpler terms, it was scattering sunlight in a direction opposite to what physics usually predicts. This negative signature means that the comet's dust particles may be unusually small or smooth, possibly coated with exotic ices or compacted in ways not found in our solar system. Such properties might arise only in the coldest and most ancient environments, deep in the outer regions of alien planetary systems where sunlight barely reaches. Even 2I Borisov, the only other interstellar comet we've studied in detail, showed positive polarization, completely different from what we see here. That makes 3I Atlas the first of its kind, not only a visitor from another star system, but potentially from a different class of small bodies altogether. This strange light signature could hold the key to its birthplace. If the dust grains are unusually pure, smooth, or crystalline, they might have formed in an environment untouched by heavy elements, perhaps in the earliest generation of planetary systems in our galaxy. With every new observation, 3I Atlas challenges what we thought we knew about interstellar comets. It doesn't just reflect sunlight, it bends and twists it, carrying with it the imprint of a world long vanished, written in the subtle language of light and shadow. In early September 2025, as professionals continued to study 3I Atlas with some of the world's most advanced telescopes, a surprising discovery came not from an observatory, but from the amateur astronomy community. During a total lunar eclipse on the night of September 7th, two well-known skywatchers, Michael Yeager and Gerald Raymond, were photographing the event from Namibia when something unusual caught their eyes. Amid the deep red glow of the eclipsed moon, they noticed a faint emerald green comet drifting through the background stars. none other than 3I Atlas. Their images quickly spread online, capturing the attention of scientists and astronomy enthusiasts alike. But this discovery posed a mystery. 3I Atlas wasn't supposed to glow green. In comets, that striking color usually comes from diatomic carbon, or C2, a molecule that fluoresces when energized by sunlight, emitting light around 518 nanometers in wavelength. It's a familiar sight for bright comets in our solar system, and it often signals that carbon molecules are being released as the comet warms. The problem? Just weeks earlier, spectroscopic studies from the Gemini South Telescope revealed that 3I Atlas was severely carbon chain depleted. It showed strong cyanide emissions, but almost no C2, a chemical fingerprint suggesting its environment of origin was poor in heavier carbon compounds. In short, it shouldn't have had enough diatomic carbon to glow green at all. So why did it? One theory suggests that as the comet moved closer to the Sun, C2 production suddenly ramped up, triggered by the exposure of new volatile layers beneath its surface. The comet could be breaking apart slightly or venting material from deep within, regions where diatomic carbon remained trapped since its formation. If true, this means 3I Atlas is changing before our eyes. It's not just active, it's evolving, revealing new chemistry as sunlight excavates fresh layers of its alien ice. The green glow then isn't just beautiful, it's evidence of transformation, perhaps even the first sign that the comet is beginning to destabilize. No modern astronomical discovery seems complete without a touch of controversy, and 3I Atlas was no exception. As the data poured in, one name began to dominate headlines once again: Dr. Avi Loeb, the Harvard astrophysicist famous for his provocative theories about interstellar visitors and alien technology. Loeb first gained attention years ago for suggesting that oumuamua, the first known interstellar object, might have been an artificial probe, perhaps a fragment of alien spacecraft propelled by light. When 3I Atlas entered the scene, he quickly turned his focus toward this new visitor. In July 2025, Loeb published a paper arguing that 3I Atlas was too large to be a natural object, based on early estimates that suggested it was around 10 kilometers across. He claimed that, given what we know about the density of interstellar space, such a massive object entering our solar system should be extremely rare, almost implausible. His conclusion, controversial as always, was that an artificial origin could not be ruled out. Within weeks, he doubled down, co-authoring another paper bluntly titled, "Is the Interstellar Object 3I Atlas Alien Technology?" The idea caught public attention instantly, reigniting debates about intelligent life beyond Earth. But as new, peer-reviewed data arrived, Loeb's hypothesis quickly began to unravel. Observations from Hubble and JWST had already revised 3I Atlas size down to no more than 5.6 kilometers, and most of its brightness came not from a solid surface, but from its coma, the cloud of dust and gas surrounding the nucleus. In other words, the measurements Loeb had used were outdated. Other scientists swiftly responded. Researchers like AKM Iasanul Hake published detailed rebuttals showing that the comet's trajectory and motion could be explained entirely by natural gravitational forces, with no need for artificial acceleration or maneuvering. The mysterious course changes Loeb mentioned turned out to be well within expected limits for an active comet releasing gas. While it's exciting to imagine alien origins, responsible science demands that we exhaust every natural explanation first. Jumping to conclusions too soon doesn't advance our understanding, it muddies it. In the end, 3I Atlas remains extraordinary not because it might be alien technology, but because it doesn't need to be. Its natural behavior, its speed, its chemistry, its bizarre light scattering already tells a story stranger and more beautiful than fiction. As 3I Atlas completes its close encounter with the Sun, astronomers around the world are now reflecting on one of the most anticipated moments of the year. On October 30th, 2025, the interstellar comet reached perihelion, its closest approach to the Sun at about 1.4 astronomical units, roughly the distance between Earth and Mars. At that point, sunlight struck its surface with maximum intensity, triggering visible changes that many telescopes are still analyzing. Early reports suggest that 3I Atlas brightened significantly, developing a more prominent tail and coma, though whether it survived intact or experienced partial fragmentation remains under study. For astronomers, this was a rare opportunity to watch an interstellar visitor react under the heat of our sun, revealing layers that have remained frozen for billions of years. Each outburst, each shift in brightness tells us more about what lies beneath its ancient crust. Now, having just passed behind the sun, 3I Atlas is temporarily unobservable from Earth, but not for long. By early December, it will re-emerge from solar conjunction, and missions like SOHO, Sphere X, MAVEN, along with continued monitoring from Hubble, James Webb, and Gemini, are poised to resume their observations. Even after this milestone, the greatest questions remain. Where did 3I Atlas truly come from? How long has it wandered between the stars? And how many more like it are drifting unseen through the darkness? Every new measurement will help piece together that puzzle. Not just about one comet, but about how planetary systems form, evolve, and end across the galaxy. 3I Atlas may now be on its way out of the solar system, but the data it leaves behind could reshape how we understand the origins of worlds themselves. It's a reminder that even after the moment of closest approach has passed, the discoveries are only just beginning, and every interstellar visitor carries with it a small but profound fragment of the universe's shared history.